We're going to solve the following system of linear equations. We begin by writing down the augmented matrix. So the entries of this matrix comes from the coefficients of our variables. We have three variables here, A, B, and C. And then to the right of our augment, we have what we're equal to. So here we're equal to 2, 3, and 0. The coefficient for A in the first equation is 2, for B is 1, for C is -1. The coefficient for A in the second equation is 2, there's no B here, and the coefficient for C is equal to 1. And in the third equation, our coefficient for A is 1, for B is -1, and there's no C present. So let me tidy this up. Now that we have an augmented matrix, we're going to row reduce to put it in reduced row echelon form. Okay, so what we're going to do, so if you look at this, we see that our leading entry is 2 for this first row where we start. It's nice to think about this when we have a leading entry of 1. Otherwise, we have, in this case, we're going to have fractions involved. So I'm going to start just by swapping row 1 and row 3 so that we get a 1 in this first leading entry. Now I want to eliminate all of the values occurring in this column below the leading entry. So what that means is I'm going to replace row 2 with row 2 minus 2 row 1. Okay, so for this example, it's pretty easy to do it in your head carefully, but doing it on paper is also a good option. Okay, and now next we want to eliminate the 2 in the third row below our leading entry. So I'm going to replace row 3 with row 3 minus 2 times row 1. Now, below my leading entry, I have all zeros. So I'm done with row 1. And I move on to row 2, where I have a leading entry of 2. So I like to have a 1 there. So I'm going to replace row 2 with 1/2 of row 2. And now I want to eliminate the 3 that lives below this leading entry. So I'm going to do that by replacing row 3 with row 3 minus 3 row 1. Okay. And because we have fractions involved, let's do this one on the side. So I misspoke, and it should have been row 3 minus 3 row 2. So let's do this on the side. Row 3 is 0, 3, -1, 2, and 3 times row 2 is 0, 3, 3/2, 9/2. If we subtract, we get 0, 0, -5/2, then 4/2 minus 9/2 is again -5/2. Okay, so this is going to be our new third row. All right, and we are now in echelon form. We want to continue on to reduced row echelon form. So the first thing we're going to do is scale this final row so that it has a 1 as its leading entry. So we're going to do that just by multiplying by -2/5. And at this point, we're ready to start doing the upward steps. So we can see that we have these pivots moving to the right with zeros below them and to the left. And we want to eliminate the elements in that live above our leading entries. So we start at the bottom. So we're trying to eliminate this 1/2. And I'm going to move to a new slide, but what we're going to do is we're going to replace row 2 with row 2 minus 1/2 of row 3. Because we have all zeros to the right of this one, you'll see that this does not mess with our structure at all. It's still going to stay nice and triangular. Okay, so this has changed all of the other entries in this column containing that last pivot to zeros. Now we want to move on to the next row up, row 2, and we want to eliminate the non-zero entries above row 2's pivot. So we're going to do that by adding row 2 to row 1. So we're replacing row 1 with row 1 plus row 2. Okay, and you can see we are now in reduced row echelon form. And when we go to rewrite as a system, we can see that it's a really simple system. Indeed, we see that 1 times A is equal to 1, and 1 times B is equal to 1, and C times 1 times C is equal to 1. And so there's a unique solution of 1, 1, 1. A part that people often forget about when doing these sorts of manipulations is that the row operations apply to things to the right of the augment just as well as they apply to things to the left. So don't forget that part, okay? Great.